Okay, so now that we know a little bit about how to graph some polar coordinates, what we now want to turn to is how do we convert between the two different systems, this polar system and the XY system. Well, we can take any point in the plane and we can describe it both in terms of polar coordinates and in terms of its rectangular XY coordinates. Okay, so every point in the plane can be described by both pairs, xy and r theta. Of course, again, r theta can be described a whole bunch of different ways, but let's just stick with the basic ideas right now, not worry about all the different ways, because it actually doesn't matter which one, because they all have at least enough characteristics in common that no matter what way we were writing them, if we convert back to xy, we would actually come back to the same xy coordinate because they do again represent that point. So how are these related? Excuse me. Excuse me again. So one thing we can see is we have a right triangle here that we can look at. It's our reference triangle. It's actually the triangle here, but if we were in a different quadrant, it would be the reference triangle for that situation. So here's what we can say. Looking at that triangle, we notice that the cosine of theta would be the adjacent over the hypotenuse. So that's relating x and r and theta. And we know that sine of theta would be the opposite y over the hypotenuse r. So we can actually take these two equations and solve them for x and y. So that we get that x is equal to r cosine theta and y is equal to r sine theta. And so now we have the connection. If we know r and theta, then we can compute x and y by just doing r cosine theta and r sine theta to get x and y. Now what about the other way? What about the other way? How do I get from x and y over to r and theta? Well, we know that x, y, and r all satisfy the Pythagorean theorem. So r squared would be equal to x squared plus y squared. All right, that would let us relate r to x and y, and then r would be the square root, plus or minus, depending on, again, how we decide to go about figuring out theta relative to r. And then what about theta? Well, if you look at this, how can I relate theta to x and y? We know that the tangent of theta is equal to y over x. Is equal to y over x. Tangent of theta is equal to y over x. And in this circumstance, theta is chosen based on the quadrants, on the quadrant of xy. All right, so we have to solve that equation, but then we're going to have to choose the theta that matches that quadrant. Okay, the quadrant where x and y are at. Okay, so that's how we're going to do the conversion. So if we have x and y, we can use x and y to find an r. Typically for us, we'll just do the square root of x squared plus y squared. Just take the positive value so we don't overcomplicate things. And usually we'll just go with that r. And then theta, we'll solve and find the reference angle based on the fraction y over x. And then we'll put that reference angle either in the first, second, third, or fourth quadrant, and just take our standard angle between 0 and 2 pi is usually how we'll approach it. Okay. And again, we'll choose which quadrant to put the reference angle in based on where x and y actually falls at.